In today's lesson, we are going to be talking about how to determine if the two triangles that we're looking at are similar. Last time we were told that they were similar, but today we are going to be working on determining ourselves if they are similar. So the first thing that we need to realize is, just like in our last lesson, to do proportionality, we have to make sure that the lines match up with what matches. So here's what I mean. AB is the first two of this triangle. That is this line on the first triangle. It matches with the first two of the second triangle. That is this line. So that is line AB over DE. Those are both of those purple lines that I drew. Then in blue, BC, that's the second and third letter, and EF. So BC is this. It goes with EF, and that would be this one, which would be in blue. And then in green, we would have the first and the last A to C. That's this line. And then we would have D to F. That's this line. And that's this here in green. Okay, and then the angles in the order of the angles match up. So A is first with D. So angle A is similar to angle D, or congruent to is what that means. B is second. It goes with E. Angle B is congruent to angle E. And lastly, the last two, C and F. C is congruent to F. So that is how we read how to determine similarity and how we match the pieces up. We did that a little bit in the last lesson. We'll continue doing that this one. So in order to determine similarity, we need to get to the actual definition so that we can understand what makes two triangles similar. So first, we have angle-angle similarity, and we are later going to abbreviate that as AA, and not that AA, but an AA. I'll put it on this side. Okay. The definition of angle-angle similarity is if two angles in a triangle are congruent to the corresponding, I always have to stop for a minute and think about how to spell that word, angles of another triangle, then the triangles are similar. We're going to use this theorem when we are given two angles in the triangles. Two angles in both, not just two between the two, but I need to have two angles in both triangles. So if I look at this first example, I'm given a 59 right here. I'm given a 37 right here, and I don't have a corresponding 37 on the other side. And I'm given an 84 there. Well, I know that the property of a triangle is that all three angles add up to 180 degrees. So for my first triangle, if I do 180 minus 59 minus 37, I end up with 84. That matches here. And likewise, if I did 180 minus 59 minus 84, I would end up with 37. So once two angles are congruent, the third angle has to be congruent based on the sum of all the angles of a triangle adding up to 180 degrees. But we just need two to determine similarity. So we're going to look at a couple of examples and then complete a similarity statement. So in our first example, this says that angle L is congruent to angle D, and that angle K with our two arc marks is congruent to angle E. I have two that are the same, and so all I need to do is match up the pieces that match. So L is our purple angle. It matches with D, and I'm going to do a triangle symbol before I write my statement, because I want to say that not the lines or the angles, but the actual whole triangle is congruent. So triangle LKJ is similar to triangle D, and then K in blue matches with E. And F is what's left. So triangle DEF by, and then we're going to put angle, angle, similarity. All right, here in this one, I've got 70 and 76 and 73. Okay, well, nothing that it has given me is similar. I do know that this and this, both sides of R, are vertical angles, so R is congruent to R, but I still only have one that's the same. I can't do a congruency statement, so I just make a slash through that. And then I do triangle, and this second triangle, it doesn't matter what order I put it in. I don't need to match anything because they are not similar. And I'm just going to write not similar. Okay, lastly, I don't have any angles marked, but I know that J is similar to J. And then this marking right here, if you remember from 10.1, the little arrows on the line, that means that those two lines are parallel. So when the two lines are parallel, let's do a different color, I know that L and F are congruent due to alternate interior angles. And I know that E and K are congruent due to alternate interior angles. We get that from the parallel line. And so we can write our similarity statement because I have 3 angles. I only needed 2, but I ended up with 3. J is congruent to J, K is congruent to E, and L is congruent to F. So I have triangle JKL is similar to triangle JEF by angle, angle, similarity. And that's how angle, angle works. Now we are going to learn about side, angle, side. And this definition's a little long, so you might want to write a little small when you're completing this definition. So side, angle, side similarity says, if the angle of a triangle is congruent to an angle of another triangle, then we have an and, so this 2 things have to happen here, and if the included sides, I'll explain that in just 1 second, of those angles are proportional. That's what we were doing in our last lesson. We were sitting at proportions. So if they are proportional, then the triangles are similar. I'm going to kind of show you in the example what we are talking about. So our angle here is N. In this example, that is a vertical angle, and that is congruent. And then I have on this triangle on the left, the NMQ, I have these 2 sides, the 5 and the 6, that lock the angle N in place. And on the other triangle, I have, on triangle NOP, I have NO and NP that lock the angle N in place. Those are the sides that are keeping N where it should be. So I'm going to use this when I have 2 sides and an angle between them. So that angle must be between your 2 sides. So how we would set this up is this, let's change our color here. This 5, if I flip the triangle over, actually matches with the 12. So I'm going to do 5 over 12 is equal to, we'll do red. So this 6 right here, this 6, if I flip it, matches with the 10. So that's 6 over 10. Pull out my calculator really fast. Hey, that gave us a similarity statement, but this is 0.416, and this is 0.6. Oh, this triangle right here is actually not similar. That's kind of interesting. All right, so let's keep going. All right. So now we're going to state if these are similar or not. So I've got the 39 and the 39, that's the same angle. I have the side here. Well, if you notice, I have a side of a 9 and a side of a 9. So I'm going to have a proportion with 9 on both the bottom. And then 36 and 37. Because it's both 9, I can tell that that's the way it's going to line up. So this is actually not similar. So I'm going to put not similar. Okay, and then we're going to match, and then because it's not similar, it doesn't matter which direction I go, L, M, N. Okay, so here we've got, on this guy, we've got some vertical angles. Alrighty, that looks good. Then we have a 10. That's going to match with our 27 when I flip it. Okay. Oh, we've got, well, I guess we have two ways. Now that I'm seeing this, look at what that doesn't, up here, when I did that, that didn't match. But if we don't flip our triangles, let's see. If we don't flip our triangles, so let's erase all of this stuff here. All right, so we've got our green triangle here. We've got our blue one here, because these could be flipped triangles with this center angle that's the same. So what, and I'm sure some of you noticed this, what happens if I match the 6 and the 12? So I have a proportion that's 6 over 12. And then I'm going to match on the other side the 5 with the 10. Are those two? Yes, those are both 1/2. So I could write that triangle MNQ is similar to triangle. Well, the M matched with the P, so PNO. All right, so if I do it the way I have on example B, let's go back here. So if I match up the two green sides and the two blue sides, I end up with 10 over 27 is equal to 9 over 30. Those are not the same fraction. Well, let's try it the other way then, just to make sure we don't have similarity. So I have this one and I have this one. Angle A is still similar to angle A, but this time let's match the 27 and the 9, and then on this side we'll match the 10 and the 30. So I now have a proportion. And you can put the big number or the little number on top. It doesn't matter. I'm going to make this triangle number 1 on the bottom and triangle number 2 on the top. So I'm going to put my 1s on the bottom, on the top, and my 2s on the bottom. So 9 is going to go with 27, and 10 is going to go with 30. Well, 9 27ths is 1/3, which is equal to 1/3. This is a similar triangle. So A matches with A. Then B was our green, it matched with V, and C matched with U. So we actually have that. That one is by angle side, oh, nope. I'm thinking back to congruence. Side, angle, side, similarity. Okay, and then we've got this last triangle. So I think you can tell on here, this side is like we have a little blue triangle, and then we have the blue one is actually nestled inside our larger green one. So to get the sides on this one, I need to add those. Actually, let's not do that in highlighter. But I make that a pen. There we go. All right, well, 11 plus 66 is 77. And 8 plus 54 is 62. So my proportion is going to be, let's do the 66 to the 77, and then we could do the 54 to the 62. Well, 66 over 77, when I divide that out, I get the decimal point 857, and 54 divided by 62 is 0.870. They are not equal. This is not similar. So I can just make any order I want, TQR. These are not similar. All right, then we have one more. And this is side, side, side similarity. And this one's going to be our SSS, and we can come back over here and call this one side angle side. I'm going to abbreviate them. Okay, side, side, side. Similarity theorem tells us if the corresponding, I have to stop and think about how to spell that every time, sides of two triangles are proportional, then the triangles are similar. And when should we use this one? When we should use this when we know when we have all three sides of both triangles. All right, so here is what we're going to do. It's like this. They are similarly oriented, so I can set up a proportion of 9 over 18 is equal to 12 over 24 is equal to 7 over 14. Those are all equal, so these are similar by side, side, side similarity. All right, so let's practice on some of these. So, okay, let's see what we can do here. These aren't oriented the same way, so I'm going to have to do I might have to try different things. So let's say G and C are similar. So that would make GF and CD, we could try to line those up. So that gives us 33 over 44. And then we could make GH and CB line up, which would give us 23 over 32. And lastly, we could do the last side. So that would give us 42 over 55. All right, so 33 over, let's see, 33, okay, so this one, 33 over, I gotta pull out my calculator, I'm trying to do it in my head, that doesn't work. Okay, this is 0.75. 23 divided by 32, that's 0.718. And 42 divided by 55, this is 0.76. Okay, that is not similar. So we're going to go ahead and say FGH is not similar to triangle BCD. They are not similar. Okay, so then on the next one, well, I know that this part is 22 and the whole thing is 55. So on my little triangle, I know that if I subtract, I'm going to get 33 there. So I can do this, the little one, 33 divided by 55 is equal to the little one, 42 divided by the big one, 70. And then the last side is 30 divided by 50, because I always have to check all three sides. This one, where they're laying on top of each other, there's no doubt what oriented where. So 33 divided by 55 is 0.6. 42 divided by 70 is 0.6. And 30 divided by 50 is 0.6. They all match, so I am similar here. So we're going to do triangle K, and then L goes with C, and M goes with D. Triangle K, C, D. All right, so the last part of this lesson is that we're going to state if the triangles are similar or not and state how you know. So we are going to look at each of these triangles and see which statement I need to try for and then do the work to figure it out. So in example A, I have a side, a side, a side. So I am looking to see if I have side, side, side similarity. They're oriented the same way so that we can check it this way. 18 divided by 49, and you could do 49 divided by 18. It really doesn't matter. It will give you this. Your decimals will be different, but they will all be the same as each other, and that's what we're looking for. So I'm going to set mine up this way. So 18 divided by 49 is 0.367. 16 divided by 40 is 0.4. Oh, I already have two that don't match. So we can go ahead and say it's not side, side, side. My second triangle, I can call it any combination of the letters I want. It is not similar because as soon as two of them don't match, we don't have similarity. Okay, on the next one, I see a vertical angle. I'm going to mark that right away. So let's do it this way first. Let's try to match the 10 and the 25. Let's see if that one is going to work for us. So the 10 and the 25. And then we'll line up the 16 and the 40. Okay, so we're trying to see if we have side, angle, side. Well, 10, let's do some calculations. This is 0.4. Oh, we did 16 over 40 over there. This is also 0.4. So yes, we have side, angle, side similarity. This is similar. D matches with itself. C matched with T, and U and B match. So we have that one. All right, I want you guys to go ahead and try these on your own, and then you can check back on the notes key and see if you've gotten the answers right. If you have questions, please feel free to come in and ask.